What we're going to do today with this session is actually explain to you how scleral shape is important in specialty lens fitting. The people who have just gone into Ortho-K, semi-scleral lenses, and neuro-optometrists are very, very lucky indeed, because things have changed so much in the last few years that their lives are a lot easier compared to what we went through many, many years ago. You have topography machines that can accurately measure end to end of the cornea. You have shim-flux imaging and corneal scleral profiles, corneal molding, and all state-of-the-art things where we can actually measure the cornea very accurately in 3 dimensions. We also have the capability of manufacturing lenses with extreme accuracy and a lot of new generation materials, special coatings, so there's really no problem that cannot really be solved. Why would you say you need to use specialty lenses? When I told a practitioner friend of mine that, how many specialty lenses do you use? He said, why would I bother with that? Because it wastes so much time and so time consuming. And if I refit a patient a few times, you tend to lose a lot of money. But as practitioners, we're supposed to give patients the best quality vision as possible, right? So with irregular astigmats, keratoconics, pellucids, injured corneas, post-refractive problems, corneal grafts, the only way you can actually fit them and let them see clearly is by specialty lenses. Like I said, we've come a long way from what was available many, many years ago, and things have become a lot better. And now we can actually measure the cornea complete with the sclera without too much of a problem. In the old generation keratometry, you don't even think about that anymore because that's really not applicable to current day contact lenses. We always thought that the corneal shape and the scleral shape was similar to this, where you had a bulge here and a cornea here. So in the old days when scleral lenses were made, they were made assuming this was the shape of the cornea and the sclera. We now know most corneal scleral junctions are actually tangential. Okay, some a bit more so than others, and some a bit less so. But in theory, this corneal shape no longer applies. The instruments we have today can actually measure the cornea and corneal shape and actually draw out a 3D image of the cornea, so you can fit the cornea in 360 degrees with any lens of your choice. These are some of the instruments being used today. And basically, corneal molding has also advanced quite a bit. And with today's type of molds, you can actually mold the cornea very accurately and without causing much incidence to a cornea, right? And from this mold, you can actually measure this mold and then have a lens designed to fit onto this mold, which looks a nice fitting similar to this. Now, the real crux of today's talk is to discuss Pentacam with CSP, which is corneal scleral profiling, where the Pentacam actually measures the cornea 360 degrees and gives us estimates of the sagittal height in all directions. And you can actually design a lens in all directions where you have 360 degrees of the edge of the lens come round through the sclera and give you a perfect fit. And you can actually measure up to about 16 to 18 millimeters of the sclera from the center of the cornea. Now, what we used to do a few years back was, because we didn't have all these machines to actually measure the scleral accurately, we had to sort of more or less judge and assume the cornea was fairly regular or a little bit astigmatic and stuff like that. But these scleral lenses used to then tilt. If they tilt vertically and horizontally too much, then your quality of vision is not very, very good. And also, sometimes when you do progressive lenses, we also know that whether they're center near or center distance, the patient's visual axis and geometric axis don't really apply. And so what happens because of this difference, progressives don't give proper corrections. So now where we can actually measure the sclera, we can actually decenter the optics of these lenses, where we can actually do progressive corrections in Ortho-K and with normal RGP lenses, which are fitted larger so they're more centered and more stable to give this patient good quality distance and near vision. And why is it necessary to measure the cornea out to the sclera? Because with very distorted corneas, corneal transplants, etc., the lens has to sit somewhere stable, and it cannot sit anywhere on the cornea because it's too out of shape. And we try and fit the lenses to vault the semiscleral junction, because we don't want the semiscleral junction to be interfered with. That's where all your stem cells live, and you don't want to cause too much damage there. So we want the lens to sit 2 mm after the corneal scleral junction, where we can center the lens properly and put the optics anywhere we want. So now let's talk about sag heights. You can have the most distorted cornea you like, this pink line here. If you know the height and if you know the diameter, you can fit any lens which is going to vault this cornea and correct it. So the whole basis of contact lens fitting today with all this new equipment is actually based on sag heights. So what instruments can we actually use to measure the entire cornea? The Menmon does quite a good job with its composite maps. You can measure edge to edge of the cornea, and it tends to extrapolate to see what the scleral looks like. The new Menmon Meridia does the same thing, and it also extrapolates for the sclera. Extrapolation is fine, but it always doesn't really work, right? So what machines actually measure the sclera are the Eaglet SM Map 3D, eye impressions from iPrint Pro and ScanFit Pro software, the Pentacam with CSP. All of these machines then actually measure your sclera, so we can actually fit on this scleral plane to actually give you a good fitting. Once you have the measurements of the sclera, you need to convert this data in order for a lathe to actually then manufacture a lens, right? And with the current technology and lathe technology today, this data is then transferred to something what a lathe can actually understand and produces a freeform lens, scleral lens, normal RGP or whatever, with the appropriate software actually interpreting what these machines find. And the software will include what we use as ScanFit Pro and Wave software. Currently, we're using mainly Wave software, and we're looking at ScanFit Pro, which we're going to start pretty soon. So with this appropriate software, the data is then analyzed, the lens is actually then designed, and it can be any real size you want, and usually larger than the HVID of the patient, especially with scleral lenses. Why do you need lenses that actually fit on the sclera instead of actually fitting just on the cornea? Assuming you have a fairly basic Ortho-K patient with a fairly normal cornea, high myopia, the problem is with Asian eyes especially, you have very, very tight lids. And when you try and put too much suction on the lens to change the power too much, the lens tends to decenter. The other problem is also when they sleep, the top upper eyelids tend to push the lens down. Both these things cause insufficient correction. You don't get your full correction, and inconsistent correction. So some days they see well, some days they don't. With very distorted corneas, you definitely need to fit them with scleral lenses. And these scleral lenses have to actually, the edge has to sit on the sclera, right? You don't really have much of a choice. And you can pick your patients where you need to do this. And as long as your flattest point, just to your steepest point, is more than 350 microns, you don't have much of a choice except fitting a sclera. Okay? Now, this is some examples of corneas that have to have scleral lenses. This is another example where you have almost, in this one, almost 700 microns between steep and flat. and this cornea as well. And this is a corneal transplant where all other RGPs we try to fit, even very large RGPs, just desensored and moved off very, very quickly. So we didn't really have much of a choice. Now, in order to fit all these people, you really need to be able to measure the sclera and measure the scleral accurately. Plus, you also need to go over the cornea because you don't want the lens to touch any part of the cornea either, right? So you do need to have good captures with a Pentacam. And when you are measuring corneal scleral profiles, you're actually measuring 5 positions: center, nasal, temporal, superior, inferior, right? And all of them have to have good captures. If you have a bad capture, you're going to have a bad lens. There's no two ways about it. So if you have to waste time and do your captures a few times, just do it, right? So how this machine works is actually patient keeps on looking at the same point, and then the machine moves to these locations in order to get a capture. The good thing about this is that if your scans are bad, it will tell you, and it will tell you to redo them, right? These are really bad scans, but after you look at all the scans, you can actually tell, even if they're slightly bad, and the machine doesn't warn you, you still have to have it redone. The other good point is that at every point, once you finish one scan, after you have to do 5, you can actually stop, adjust the patient, let the patient rest, close their eyes, go to the next patient. The disadvantage we have in Asia, where we do all these fittings, is that Asian eyes are not exactly very, very large, and it's very hard to get full scans to cover most of the cornea and sclera, which you need for your fittings. So you need to have good coverage, and with tight lids, it's challenging. And at a conference in Tokyo, I came across a little gadget which helped us quite a bit. Let me just show this to you. Now, this is what they call an eyelid fixator, which is actually a direct translation from Japanese. Whether I translated it correctly or not, I don't really know. Let me just show you how you put this on. It's actually made of silicone, and you just put it on the eye. You strap it fairly tightly behind the head, and once it's strapped and the patient sits comfortably in front of the machine, then you pull up the upper lid and pull down the lower lid, and the silicone holds the top and lower lid in position. So you can see the difference between one eye and the other eye. One eye is fully open and the other eye isn't. And this really helps you do a very, very good capture. Once you have the eye open properly, then you start doing captures with CSP and the Pentacam. You can see you can do 360 degrees all the way around. There's some areas where you don't have perfect lines, right? So you need to decide if you're fitting up to 14 or 15 millimeters, and some of these imperfect lines are out of the range. You don't really need to worry about them too much, right? But for the sake of this talk, let's assume we accept this, and then from here, we go and start trying to design a lens. What I want to do first is talk to you about a normal Ortho-K patient. Power's not very high, about -8. And we tried about 3 different fittings with her. She had very tight upper lids, and no matter what we did, we never ever got proper corrections. The corrections were always slightly decentered, and we were correcting about 3.2 to about 4 diopters instead of the 8 diopters we wanted. And the reason is the lens kept on decentering, because if you see, even though she's looking centrally, this part is a lot flatter than the other part. And so what happens when the lens sits, it tends to dislocate, and then you have a problem. So we decided to solve this problem by fitting her with a much larger lens. Her corneal diameter is about 11.6, and we fitted her with a 12.2 millimeter lens. So we actually got into the sclera, and the lens was actually resting on the sclera. Scleral readings we got from Pentacam CSP, to make sure it was sitting centrally and not going to one side more than the other. And this was a free-form fit. And lo and behold, all of a sudden we get an 8 diopter correction after 1 day. So sometimes when you do Ortho-K and things are not working out very well, you need to have a large size Ortho-K lens. If the lens is too large, say for example 14, 14.5, that means when the patient's asleep, there will be less horizontal movements during REM, and when there's less movement, you have less suction, and you're not going to get proper corrections. So you want the lens to be larger to sit on the sclera, but you also want it to be able to move enough to get better correction. I want to talk also a little bit about progressive lenses, right? I don't know how many of you fit soft progressive lenses, but we have done this and tried, and we really have not very much success, especially in Asia. Again, top tight lids, very much smaller corneas, very much flatter corneas in some cases, and the lenses keep on buckling, move a little bit out of position, and half the time they're not seeing very clearly. The other problem we have in Asia is that individuals have very small pupils, between 3 and maybe 4, 4.5. And a lot of these progressives don't have enough in the OZ to give them good vision, distance, and near. So the ones that are center near, they can only read but they can't see far, unless it's nighttime and their pupils dilate a little bit. So the ones which are center distance, they see well, no distance, but they can't read. So what's the answer? So we try to do progressive RGPs, but a normal RGP moves too much and you can't really fit them. So you need to fit a fairly large RGP, again similar to our Ortho-K patient, a 12.2, and you can then also decide on whether you actually need to decenter the OZ of these lenses in order for the patient to look through their visual axis and make sure through their visual axis they get the central optics, which could be either center near or center distance. So let's look at a normal patient and see how their optics are actually decentered from their geometric axis. The Pentacam does this for you very well. This is the line on white to white from scleral margin to scleral margin, and you see the visual axis is decentered 0.39 millimeters temporal and 0.29 millimeters superior. So when we do a large size RGP in a progressive form, we do it in prism ballast, plus we decenter the optics as well. And this gives them the best possible correction because they're looking through the exact optics of the lens which they're using all the time. And having an RGP surface which doesn't buckle and doesn't move that much, quality of images are actually very good. So, fitting extreme corneas, right? Let's call them extreme corneas because you have nothing else to fit them with. This is where the Pentacam CSP comes into terms with itself. And with Wave software or ScanFit Pro software, you find this indispensable way of fitting lenses where virtual fits actually work, and trial lens fittings are really a thing of the past, and with COVID and all sorts of other things, the last thing you want to do is to put 5 different pairs of lenses in a cornea in and out in order to judge, oh, this is better, this might be worse, and let's order something in between. The other advantage of this is that with normal RGP fits and semi-scleral fits, you cannot really judge if the lens is tilting or it is actually fitting in a 360-degree round circle around the cornea, sitting on the sclera and not tilting and not moving off position. So let's go through a video on the fitting. We've done the scans, And these are the CSP results. It's all a matter of pressing the right buttons and things start happening. And then what the Wave software, which is actually taking all the measurements from the Pentacam and dumping it into the Wave software, is then designing this semi-scleral lens. Okay, and it will do this in meridian to meridian. Okay, it's a bit time consuming, but if you consider the amount of mathematics that goes into this, it's actually quite considerable. The corneal diameter, you can choose the size of the semi-scleral lens you want, and you choose the correction you want to correct, and then the magic starts happening, where it then starts designing the lens. And this bottom line here is actually the corneal surface, and this is how it's manipulating the lens in order to fit on this corneal surface. Okay. Okay, because this cornea is not very, very distorted, we decided to do this on a geometric, symmetrical surface where we have two meridians along the flat meridian and along the steep meridian. So instead of being in free form, we will put it in a geometric axis once this fourth meridian has been actually calculated. And this is where my staff fell asleep and didn't press the G quickly enough. Okay, here we go. Right, so now we have a nice semi-scleral lens touching at this point of the cornea and this point of the cornea. You can do anything you want with this lens. You can move the edges up and down. You can move the sag higher and lower. You can reduce the OZ, you can increase the OZ. So everything you can manipulate. You don't need to manipulate for the whole lens. You can break this down into 25% steps, and you can do this in actually 8 meridians if you wanted to. So at every meridian, you can make it tighter, flatter, or whatever you want to do. You can also adjust the edge to 45-degree angles, 41 and 37 degrees angles. So there's so much you can do with this, and from here you just go to orders. The order goes directly to Wave. Wave then sends it to the lab. The lab takes the data, dumps it into the lathe, and lo and behold, a lens comes together with a nice bill, of course. Okay, but that's part of life. Okay, so this is what will be your lens which you receive. You have a nice clearance throughout the whole cornea. You have a little bit of a ring around the limbus. You have touch on the scleral junction, on the sclera, and you have a little bit of a nice edge, right? You have to make sure you are not pinching onto the little vessels, and you need to make sure you're not touching the corneal scleral junction, like I said, which is not very good for the eye. And after you've done this and you do OCT on the front surface, you will find you have a very nice edge, you have very nice clearance centrally and on the edge, and that's your corneal scleral junction. Touch is only about 2 millimeters down, and you have a very nice edge lift with nothing pinching onto the cornea. So we couldn't go through very, very much detail, but I think there's enough detail here for you to understand that if you want to do these type of fittings, there's so much help out there for you with the right equipment, and a lot of companies which actually design these things offer a lot of help, a lot of webinars, and you can get started without any issues at all. I thank the organizers for inviting me, and for you, all the audiences pretending to listen to this. Thank you so much. Good night.